Today we're going to be looking at a remote automatic antenna switch that I made to switch between a dedicated receive antenna and an antenna that can be used for transmit or receive. The original intent of this I'll get into in just a minute, but this unit right here will switch between two different antennas, and I'll go into details and how I built it here in the next few minutes. So let me talk for a minute about what the original intent was. When I started this project, the original plan was to just make a remote antenna switch that I could sit in front of my radio inside my radio room and switch between two different antennas. So I put it together with an A and a B port for antenna A and antenna B, but it morphed into something else that I'll go into in a little bit. We'll look at the box itself that contains the relays for the switch, as well as the control box and what it does, because this current configuration offers a lot of options. So when I started this, I began with the intent, like as I said, to have an A and a B switch that I could operate from inside the house. This is the box right here that contains the antenna ports, and then we'll go into the control box in just a minute. But what you can see right here, this is the input, the antenna that comes, the coax that comes from the radio. It splits off into the center conductor right here, and then you have the shield right here that goes to the other side. What I've done is, this is a double pole, double throw relay that can be purchased off of Amazon. And I think you can see the part number right there, JQX62-2C. And that's the relay that I'm using, and I'll go into how well it works in just a minute also. But when the relay operates, it goes to the side right here that will allow you to go between two different antennas. What we have here, this is the B port for the antenna, and this is the A port for the antenna. When the box is powered off, it defaults to the A port. If there's no power, it defaults to A, which is my normal transmit and receive antenna. There's some fail safes built into here that we'll talk about in a minute. So if there's a power failure or something happens, it always defaults back to the multi-band transmit antenna. Let's look at one other thing for a minute. Let me pull this cover off. Let's see here. It's not quite cooperating here. Let's stand by for a second. Okay, now that we have the cover off, we can do some testing here. One thing I did want to mention that we'll talk about more in detail later is the insertion loss. And I've got this hooked up to the Nano VNA, and you can see here probably this is from the 1.8 megahertz, the 80 meter band, all the way up 330 megahertz. There's a little bit of insertion loss as the frequency increases, and we're going to talk more about that in a second. But basically, from the 80 meter band to the 20 meter band, the insertion loss is less than a half a dB. When you get up to the 10 meter band, around 28 megahertz, the insertion loss increases to about 1.5 dB. So as the frequency increases, the insertion loss also increases, which I kind of expected that. But with this current setup right here, you would not be able to work the 2 meter band with this right here, because your insertion loss would be up to about 7 dB, which to me that would not be acceptable. You'd have to go with some other type of switch configuration. But that's the insertion loss. And as we'll see right here, and because there's nothing on this port right here, we're going to see some a waveform you may not expect, but it's different when it's all connected up. But anyway, let me just show the operation. What I'm going to do is operate the relay right here, and we'll see it switch between A and B. So this is the A antenna, and this is the B antenna. So you can see it drops off as the relay operates. When there's 2 antennas hooked up, you get a little bit different waveform. But anyway, so this is the box right here. Let's go to the drawing. We're going to pause for a second and go to the drawing, and then we'll talk about what else this does. So stand by. Okay, so this is a rough sketch of what we've got and how this works. Let me just put out a little bit of a disclaimer here. This works for my radio and my setup, so I cannot guarantee that it will work for what you have. And if you do this, I'm not, and I'm not telling anybody that they should do this or this is the only way to do it. But if you attempt this and you mess up your own radio, well, I'm sorry, but I'm not telling you to do that. Do this at your own risk. So with that behind us, let's talk about this for a little bit. We've talked about what's in the black box, which was this right here. And on this drawing, the black box is this area right here, right in here. So there's not much in the box. But let's talk about how this thing operates. First, I have a 12-volt power supply. This is just a little power supply that used to feed a satellite TV receiver that I no longer have. But I kept the adapter that went from 120 volts to 12 volts, and that's how I power this. So as you see, we've got our ground here, but let's just follow the hot wire. When it comes in, the 12 volts goes to a power switch, which we will look at in a second. Well, let's look at it right now. The power switch is on this box right here. This is the power switch that provides power to the relay box. What this switch does is when the switch is closed, it provides power to this lamp. I'm using an LED in my case. It also comes down here and provides power to another relay, which I've called a power fail relay, that I have wired for normally open. So when power is applied, the power goes through this coil and closes this relay. Again, that power switch is this one right here, what I'm calling S1. All right, so it comes through there and it goes to another relay right here. And we're going to talk about this switch in just a minute. There's another wire that comes off and goes to another switch. But anyway, it goes to this relay right here. And let me get the relay and let you see what that is. And we'll talk a little bit more about that. These are some relays that I picked up off of Amazon. They're basically low power relays that I use to control which antenna is operating, and I'll go into how that's controlled here in just a second. But basically with these relays, these are your control leads right up here that control the relays, and this is a normally open or normally closed relay. It works on 12 volts in my case, and the control leads are supposed to be, according to the specs, optically isolated from the relay itself. So these control leads right here do not tie into where the antenna is. And I'll tell you what my concern is, or was, about that in a minute. Also, I'll try to remember to tell you why I did this setup right here. This was a test just to see how well these relays operated. And we'll maybe talk about that in a minute. So the relay that I just showed you is right here. And how this is controlled is on my radio, which is the FT710. I pulled off, or I didn't pull it off. I'm using the control leads from the linear port. And let me get the drawing for the radio. What we see right here is there is a positive 13 volts, a ground, and a transmit ground. These three leads I use to operate the relay. So what we've got here is the coil of the relay is tied to 13 volts and ground, and the push to talk or transmit ground is what I'm using as the trigger for the relay. And how that functions is when you hit the push to talk button on the radio, that pin goes low and it triggers that relay. So what it does is it closes this, or actually it opens this, because I keep this normally closed, and we'll get into that in a second. So this relay is tied normally closed, and this relay is tied normally open. But anyway, let's keep going here. So as you move down through here, there's another switch, which is the secondary switch right here. This is my S2 switch, and what that switch does is it will force the black box with the relay in it to stay on the B antenna all the time. And I had that for use when I'm testing antennas, and let's say I want to transmit over the B antenna, it will stay on the B antenna when I transmit, because otherwise it does not. Again, this is the power fail relay. If we lose power to this up here from the adapter for whatever reason, if we lose power, this coil loses power and this goes open. And what that does is that will force the antenna box back to the multi-band transmit receive antenna. As I go down too, there's one more lamp. I'm using an LED, but it just you can put any kind of light indicator here that you wanted to, tied to ground. And when there's 12 volts at this point, you see the antenna B on line light comes on. And I did that so that I would know whether whether antenna B was online or antenna A was online. So you wonder, okay, how does this control box right here, which is within the dotted line, how does this control box get to the black box? Well, I've got a 2-conductor cable right here that goes to the black box. And what it does is when there's power on this cable, it energizes this coil and will operate the relay this way. If there's no power here, the relay goes to the other side. So what we see, when there's no power applied, antenna A is going to be online. When there is power applied, antenna B will be online, which is my dipole receive antenna. It's currently my dipole receive antenna, but this could be used for any kind of antenna, any kind of testing. And let me give a little example. I'll go over it first, and I'll give you an example of how it works. So when switch 1 and switch 2 are both off, and when you look at the box here, this is switch 1 and this is switch 2. When switch 1 and switch 2 are both off, antenna A is online, and it's always online. So any transmit or receiving will come across antenna A. When switch 1 is on and switch 2 is off, antenna A will be the antenna used for transmit, and antenna B will be the receive antenna always. So what you'll have when 1 is on and 2 is off is this is active from the push to talk button, and I'll give a demonstration of this in a minute. From the push to talk button down through the box, and it operates as an automatic transmit receive switch in this black box that will allow you to switch between antennas. You can have a transmit antenna and a receive antenna. All right, and let's continue on to the last one here. If switch 1 is on and switch 2 are on, what it does is it closes this right here. It bypasses the push to talk relay and forces antenna B to be online all the time. So let's say you had 2 antennas that you were testing out and you wanted to test the performance between the 2. All you would have to do is if you wanted to stay on A, you have 1 and 2 off. If you wanted to stay on B, you have 1 and 2 on. If you wanted to toggle between the 2, you have 1 on and 2 off. So that's kind of how it works. And let me give just a little demonstration of how this functions real quick. So let's turn on switch 1, and you can see here what this shows is that we have the B on, the B receive, and this is the second LED. This is the receive antenna LED. They're not labeled. I need to label these. And this is the power LED. So we see we have power and it's on antenna B. Switch 1 is on, switch 2 is off. When I press the push to talk, you can see that it switches back to the A antenna because the B antenna light will go off. Let's do that again. So what that does is that switches the antenna to the A and to use the A antenna when we're transmitting. Now if I turn on this switch, this is going to force it to antenna B. So watch this right here. We'll press it again. And you can slightly hear the relay inside the box. And I'm hooked up to a dummy load, so this is not transmitting, so there's no need to throw out my call sign. But again, so this is antenna B. Both LEDs stay on. Antenna A. The antenna B light goes off and it switches. And just so you can see this happen in real time, let's see if you can see this. So you can see there, it goes to the top set of contacts when it's powered up, or when it's transmitting, and it's on the bottom when it's received. So that's kind of how this works. I've been pretty satisfied with it. I do not have the antenna that is not in use tied to ground at this moment. And I don't have the grounds tied together. The reason why is because I wanted isolation between the shield and the center conductor between the two antennas. I didn't want the grounds tied together. And the reason why is because I was originally doing this to try to eliminate noise and isolate noise problems. If I could do later, or I may do this later, is make this multiple ports. So instead of having just an A and a B antenna, I could add a C antenna and a D antenna. What I would do is add additional relays, and I would take, when the antenna is active, it would be connected to the coax. And then it'd have, or when the relay is active, it would be connected to the coax. And when it's not active, I would have both the center pin and the shield tied to ground. And that would provide grounding. But so far, I've had very good success with this right here. This is just a standard relay. It's got the only thing that I've got a diode across the coil right here, reverse bias, so that when the relay's powered off, there's no induction, or when the field collapses, it doesn't cause any kind of issues, and that's worked out real well. But again, this is an automatic remote antenna switch that can be used to have a transmit and a receive antenna. Switches automatically when you hit push to talk, or you can lock it on one antenna or the other so that you can do testing between antennas. So I think that's everything that I've got on this. The insertion loss. Oh yeah, what I was going to mention on the insertion loss. I had taken, and to see if the insertion loss would be better or worse than this large relay right here, I did a test with these right here to see what the bandwidth of these relays were. And they are not as good as the larger relay is. I think the small relay, by the time you got to 28 megahertz, you had an insertion loss of about 7 dB using the small electronic relays right there. You had a much greater insertion loss with that than you do with this right here. So I think that about covers it all. Powered with an old adapter, 2 relays in there. These relays were about, I think it's $6 off of Amazon for 4. The LEDs came in a pack of 5. Oh, and the reason that I went with this, I originally intended to only make a remote antenna switch, not anything automatic. But when I got started, I realized, I've got these parts left over. What am I going to do with these parts? Because otherwise, if anybody else is like me, you lose extra pieces. So I got to, it just dawned on me, I'm one step from an automatic antenna switch that'll switch when I do push to talk, which prompted me to do this right here. So anyway, I hope that this is beneficial and helpful. I'll do a little slow, I'll hold this right here for a minute so that people can maybe see it. Again, I can't guarantee that this would work in your situation. And if you try it, just as I did, try it at your own risk. Do testing before you hook it up to your radio to make sure everything's operating properly. But I hope this has been enjoyable. We had some questions about this when I did the last video. Go check out the previous video about reducing noise, because that's what inspired this box right here. So go check that out if you want to. And if there's any questions, put them in the comments. I'll try to answer it. I try to get to all those. But anyway, if you enjoyed the antenna, give it the video, give it a thumbs up. If you like the channel, go ahead and subscribe. I've got more videos coming up, and that should be coming up maybe by next week. So anyway, have a good one. I appreciate it, and see you next time. Bye-bye.